the end of last year, the tax code was a piecewise defined function. For people earning between 40,000 and 60,000, there is a function that gives us the tax that they have to pay. For people between 60 and 80, there is a different function that gives us the tax that they have to pay, and so on and so forth. That's a typical piecewise defined function. A different function for different x values. In your book, on page 252, I would like to start with an easy problem. I can't find something that I need, so I'm going to make one up. Let's say 2 minus x for x less than or equal to 0. And 2x plus 8 for x greater than 0. This is a piecewise defined function. It's defined in how many pieces? 2 pieces. Now, what is very important to understand here is this. For certain x values, I will have a certain graph. For other x values, a different graph. They cannot overlap. The graph from negative infinity to 0 cannot go on the other side and overlap with the graph from 0 to infinity, and vice versa. So I've seen it so many times. Students graph something like this. No, no, no. You can't. So there is one graph for certain x values and a totally different graph for other x values. But they cannot overlap. You cannot bring this function over this function and this function over that function because they are totally separate. Very good. So how do we start? Of course, the question is graph. How do we start? Whenever I'm asked to graph a function, what do I have to do first? Always. That's a key. That's the first step. Very important.
I'm going to say find the y-intercepts, but that sounds wrong.
On your axis.
That's the key. Every time we graph, that's the first thing we need to find. Because I don't know where to graph it. Thank you. Always. Always the domain is the key. Before I find the domain, I can't do anything. Very good. Thank you. Ready? So I'm going to ask you to look at this piece and give me the interval notation for that. Just replace it with the interval notation. Tell me how to write it.
X is less than or equal to 0.
Interval notation.
Negative infinity to 0 bracket.
Awesome. That's what I needed. Very good. Now let's look at this one and do the same thing. Let's
0 infinity.
Very good. So now let's look at this piece and conclude. What is the domain of the entire function? I want the domain of this. I know the domain of this piece is that. I know the domain of this piece is this, but I want the domain of the entire function.
The entire function technically is all real numbers.
Correct. That's what I needed. The function is defined between negative infinity and 0. It's defined at 0, and it's defined between 0 and infinity. Nothing is missing. Well done. I get my chart going. This is the domain from negative infinity to infinity. And now I'm going to ask you the next question. Which x value must be in the chart and why?
0.
Why?
Because that's what it's defined by.
Nope. Say it again. No. I need to have 0 in there. Why? Because at that particular x value, something major happens. What is that major thing that happens?
It changes from one function to
That's
the other.
it. That's the answer. It goes from this to this. If I don't know what happens exactly at that point, then I can graph. Very good. So here's 0. right underneath 0, I'm going to put in this symbol facing left, right exactly under 0, this symbol facing left, and this symbol facing right, and they are touching. Bear with me, I'll explain. You'll see it will be very clear in a minute. Now I'm going to ask you something that is an overkill, but I need to see it right there in front of me. What function will you use for x values between negative infinity and 0? I want to write it up here.
F of x equals 2 minus x.
Which function will you use for, I know it's an overkill, I want to write it up here.
2x plus 8.
Do you all agree with 2x plus 8? Okay, perfect. What type of functions are these? This is very important, because if they are quadratic, I need a certain number of points. If they're linear, I need 2. If they are square root, then I need 3 points, and so on and so forth.
Linear.
Linear, perfect. So please give me a value here, and give me a value here.
-2 and positive 3.
Very good. Okay, so please plug in -2 and tell me the answer.
2 minus 0. No, -4.
We agree with positive 4?
Right.
Good.
Minus negative.
Now I'm going to ask you to plug in 0.
2.
Do you all agree with 2? Okay. Now I'm going to ask you to plug in 0 on the other side. What would you say first?
It won't work.
Exactly. I'm not allowed to. I'm not allowed to plug in 0. Look, it's a parenthesis. I cannot plug 0 here and here. However, I'm going to say bear with me and plug in 0, and I'll explain.
2 times 0, 0 plus 8 gets you 8.
Okay? And now please plug in 3.
6 plus 8.
14.
Good. Now, let me explain first why I allowed myself to plug in 0. If I don't plug in 0, I have to plug in this function, the closest number to 0. I don't know what the closest number to 0 is. It's 0.0000000000. Right. Instead, I allow myself and I plug in 0, but I will leave it as a open point. So this point does not exist. It will be an open
It
point.
reaches every number up to that, but not including.
Right. So ready to graph? The first ordered pair that you will ask me to plot is
-2, 4.
the next ordered pair that you will ask me to plot is
0, 2.
full point or empty.
Full.
We know that this is linear, that's why I'm graphing a linear function. You understand that this function cannot go to the other side of x values. It has to end where it is. So between -infinity and 0, I graph this function, and this is it. Now, on the other side, you will say, plot what first?
Open point of 0, 8. And then 3, 14.
You understand that the purple graph, one more time, cannot go to the other side. And you understand that the green graph cannot go to the other side, to the left side. The purple cannot go to the right, and the green cannot go to the left. If I make that mistake and extend these, is this a function? No, not anymore. By the vertical line test, it's not going to be a function. Good. Of course, I'm going to ask you to determine what? Thank you, of course. One of my professors that I really admired, he would write his tests, and I'm not kidding. He would write his tests only 5 minutes before the test. And he always explained why. He said, well, you are in my head. You may know what I'm going to put on the test. So that's Brian. So I just had a thought, and he...
Range would have to be 2 to bracket 2 to infinity.
You all agree with 2 to infinity? Any questions? Any questions? Okay, last item for today. Difference quotient. Difference quotient. What is this? And what is it used for? The difference quotient for a function will give us the rate of change of that function, basically at any point. Like, for example, if I have a graph that is the distance, the rate of change of that graph will give us the velocity. Okay? If I have the acceleration, no, I have to go backwards because that would be an integral. If I have a volume that changes, that I have a function that represents the volume, the difference quotient for that function will give us the rate of change of the volume with respect to time, and so on and so forth. It's not a difficult concept, but it's a lot of work. So let's try to understand what this means. So let's say I have a function. So here's function f of x. So if this is x, what does this mean? Or what is this value?
F(x).
Of course. And I'm going to say that this is x plus a little bit. A little bit is denoted by h. So you can say, but this is not a little bit at all. And I would have to agree. It doesn't seem like this is a little bit.
It's relative.
The reason I use such a huge, or I zoomed in if you want, is because I would like to show you it's easier. If I plot here x plus h, nobody will understand or see what I'm doing. Okay, but this is a little bit. Can anyone give us the coordinates of this point?
F of x plus h, right?
Right. So this is x plus h, and this must be f of x plus h. So for a minor change in x, we want to see what is the change in y. That's the idea. So I would like you to draw the line connecting. It's called the secant line. The line, but not the trig secant. It's just a line that crosses the graph into. It's a different, yes, it's a different type. Okay, so I would like you to give me the slope of the secant line. Can anyone refresh our memory on how to determine the slope of a line given 2 points? Correct.
It would
So-
be h then. Slope would be h.
So rise over run. So what is the rise represented by?
f(x minus h minus f of x).
Yes, you're right. So I just wanted to write the definition. Y2 minus Y1, you're right. Over x2 minus x1. So now we are ready to write this. So one more time, Brian, if you'd like to say it.
F of x plus h minus f of x
Very good. Over.
over x plus h minus x.
Very good. This is the difference quotient. Very good. Awesome. Of course, I'm going to simplify, combine like terms, these two. So the difference quotient dq is f of x plus h minus f of x divided by h. And I would like to pick a function and determine its difference quotient. On page 252, let's start with 78. On 252. And we have f of x equals x squared minus 5x plus 8. Okay, so I'm asked to find dq for this function. I see here three different pieces. I see this piece, I see this piece, and I see this piece. Which two pieces I can do anything to? Or I don't need to do anything to?
F of x plus h and f of x.
No, that one I don't have. That's the only one I have to work on hard. I don't have this one. This one is the only one I don't have. This one is clear, this one is clear. F of x is given, and h is just h, a little bit. So I have to find f of x plus h first. So let's try. We just did an example, and I pointed out how to fill it in. So what do I have to write in order to find f of x plus h? It's similar to finding f of negative x. It's similar to plugging in anything.
Just plug in x plus h for x.
Correct. So can anyone dictate other than Tom?
Not as tired as you are of it.
It's awesome. I have to say it quickly, faster than you are opening your mouth. So anyone?
Write down the answers.
Parentheses x plus h squared
Awesome.
minus 5 parentheses x plus h plus 8.
Thank you, Eddie. Okay. Before you say anything, I just need to avoid this. Okay. We are coming back to our agreement. Careful, right? And now you tell me how to continue to simplify this. Before I put the piece in there, and this piece, and put them together, I need to simplify this. Yes, Tom.
X squared plus h squared minus. All right. Difference. Okay, thank you. Difference of squares. So
My lips are sealed.
wasn't anything you said, so. X squared minus h squared. I see no reason why it would be that.
X squared plus xh.
X squared plus 2 extra h plus 3 squared.
Please remember, we don't want to fall behind. This is absolutely crucial. It will pop up almost in everything, right? So we have to use this formula. The first term squared plus 2 times the first times the second plus the second term squared. Please. Good. And now I distribute negative 5x, negative 5h plus 8. And now I'm ready to put all pieces together and find the difference quotient. Can anyone dictate? Other than Tom.
I actually don't think I can.
Yes, you can.
I could if I
So
really wanted to.
I need this piece. 1, 2, 3, 4, 5, 6 terms. So these 6 terms make that piece. Are you with me? Yes? Yes? But is it clear? We just simplify that. I have to put it in. So x squared plus 2xh plus h squared minus 5x minus 5h plus 8. I'm done with this piece. Only. I reach this symbol. Minus f of x. Can anyone dictate? This is our f of x. And I want minus f of x.
Negative x squared plus 5x minus 8.
Good. And the denominator now. Very good. 2 things must happen here. Every time you determine the difference quotient, 2 things must happen. The first thing that must happen is all terms that do not have h at the top must go away. If they don't, something is wrong. Then at the very end, this h in the denominator must go away as well. So can anyone dictate terms that go away from the top?
Negative 5x.
88.
All terms that do not have h must go away. How many terms are left over?
3.
Yes. 1, 2, 3. They have a common factor. Very good. Awesome. We have to answer faster than he can think, so otherwise
While you're
we can't
doing
get,
it,
we can't get in any word. Okay, so then, can anyone tell us what is left at the top? Other than top.
2 h times 2x.
So,
Yeah. Plus
so one more time the first term. One more time.
2x
Awesome.
plus h
Awesome.
minus 5.
Do you all agree? Let's check. 2x times h is 2xh. H times h is h squared. H times negative 5 is negative 5h. What do you think will happen next? That's the second thing that must happen.
h below got to go away.
Exactly, the 1 in the denominator has to go away. And this is final. This expression gives us the rate of change of this function at any point.